Right after the beginning.
Hello.
Well, it's like.
You can hear me though, right? Do you have any more time with D6? So we actually had these towards the beginning of the year. It's just a relationship between cotangent, tangent, secant, cosine, and cosecant and sine. When I make this one. Okay. Does anybody want to sit at the desk? Justin, will you sit at the desk? Yeah, will you? Take notes there. I need you to scroll. I need you to scroll.
Oh, I was going to say, because I was talking.
You're going to need to know. So scroll for me a little.
My phone.
Good. Okay, so we've kind of experienced these ones as well because tangent is y over x, and the unit circle sine represents the y, cosine represents the x. Cotangent's x over y. In the unit circle, cosine is the x, sine is the y. So we've kind of experienced this already. Scroll. That's good there. We can get them both. That's it for identities for today after this paper. Okay, so for the negative angle identities, I just wrote that it's true for all functions rather than have you write every single one like this. If it's sine of a negative angle, it's the same as the negative sine of that angle. Same thing for all the other ones, cosine, tangent, cotangent, cosecant, secant. just as like a side note, if I know what the cotangent of an angle is, cotangent squared is just whatever that ratio is squared. So if cotangent's, I don't know, √3/2. Cotangent squared is √3/2 squared. Everybody got them? Okay, so I meant what I said. You got to buckle up a little bit, or else this will take longer than you'd like. Okay. Yep. Scroll. Keep going. Keep going. I need to get this stuff on top. A little bit. Give me a little more. Good. All right. So there's three styles of three types of ways that I'll ask you questions for these types of identities. So we'll do a couple of each different. Yeah, this is not in your notes. So this does not go on the identity sheet. You can get it the way we used to, but I'm going to teach my show. Are you trying to? Let's name it. All right, so just quickly too, I'm going to give you some practice to do today on this, and then after your quiz on Thursday, I'll have some more practice for you to do, and then there'll be a Todd. We're bringing Todd back.
So what's the point of you having two keyboards? You don't mind me asking.
I think eventually you're going to take that keyboard away. It's a lot nicer to type on the regular keyboard than the laptop. Okay, so using identities, we're going to take knowing the tangent of an angle is -5/3, and we're going to figure out what the secant of the angle is. So I'm looking at my identity sheet. You should still have it out. And under the Pythagorean identities, I can see that tangent and secant are related in one of those. So on a quiz and a test, I'm going to ask you to identify first the identity you're going to use. Sometimes there's more than one. So I know what tangent of theta is, so I can plug it in. This is tangent squared, so I have to square that -5/3. It's going to determine the sign of our plus or minus of our primates, not SIN, SIG. So we'll just clean up the left side. It's not that bad.
Yeah, it does.
I said it does.
Need it. Just okay.
Okay, so first of all, from green to the first blue, each of these gets squared.
Oh.
So 5 squared is 25, 3 squared is 9. The negative will will create a positive. Negative squared is positive. 1 in ninths is 9 ninths. So 25 plus 9 is...
I said it. I don't know.
That's what you said.
Hey, this is my show.
I asked you. He said it.
So 25 plus 9 is 34. You with me? Yeah, so now we have to square root both sides because I want to know what secant is, not secant squared. Square rooting a fraction, I can just square the top and I can square the bottom separately. So on top I get the square root of 34. On the bottom, square root of 9 is just 3.
That wasn't too hard.
And that's the
Can you
answer.
just keep it up?
But I'm not quite done yet.
Oh, yep.
It's in quadrant 2.
Oh, okay.
Oh, so you put at the start.
Secant is r over x. In quadrant 2, x is negative, so secant is negative. So it's negative root 34 over 3. Yeah. Yeah. Remember what we talked about in the first unit. If you are telling me that something's negative, make sure that I can see the negative sign. So if you're the type of person that writes when it's small, make sure I can see the negative sign.
So this is basically what we did. You make that real first.
Yeah. So this is another way to take one function value and find another.
Ew.
See?
Okay.
Oh, yeah.
I'm not lying.
Okay, so I picked the identity that relates them. I plug in what I know, and then I simplify. So the next two are based off of this one. So we're going to need the fact that secant is negative root 34 over 3 to be the next one. So the next one. It'll go away. Watch. Magic. Whatever. So same information. This time I want to know what sine is. Okay, so this is where it gets a little bit tricky.
Yeah, I got it.
So we know tangent and we know secant, but you're assuming that the angle is one of our special.
Mr. P, so we have to use this tan equals negative 5.3 for all 6 of them to figure it out.
Yeah, if I ask you that. So, but we now know secant. So I'm gonna do something different. No, I'm recording.
Oh, good. It's
Yeah.
recorded. That's on there.
So you can always go back later. Actually, watch the video. So I'm going to use that relationship because I know that cosine squared theta is the same as 1 over secant squared theta.
It's gonna end my life right now.
Mr.
Huh?
Will it stay on the test?
On a test?
On
It will be on a test. It will be on the Unit 3 test.
But not B test or anything.
Why would I do that?
So what's the unit 3 says? Thursday.
When?
Good.
Right before
Thursday.
winter break.
Oh, so wait.
That's so long.
So, I chose this one again, this Pythagorean identity again, because I can make cosine into secant, and I know secant. I'm gonna move this 1 over secant squared to the other side by subtracting it.
Yes. Is there any particular
What's that?
where did you use that?
Because I knew I could have sine and secant related. I think there's another way to do it. So.
The other way easier.
It's all relative.
I feel like you just think really
So now I can plug in secant.
This one you gotta write really small. Try to fit it in between the lines.
So don't fit it in.
Or you could use 2 lines.
Yeah, but then it just looks so messed up.
Alright, so this is it. This is the end. It's been a long day.
How many questions do you think Primo's gonna ask me?
Will the answer be your mom? Oh, I'm gonna say 5.
What's the over under?
I say about 1 over 34 over 9. Yeah, that makes a lot of sense. Equal to 3.5.
Really?
Where?
Yeah. Lost the average.
You lost me running around
Here?
sine squared plus
Are you good here? Up till here? So I plug this in there.
Oh. Okay. Well, I got it.
Good. Now?
Yeah.
This squared is 34 over 9. And then 1 over 34 over 9 is the same as 9 over 34. Huh? Yeah.
Okay.
And then 1 is 34 over 34. 34 minus 9 is... I think I did it different in the last class.
Alright, I get it.
It's still relatively complicated.
Wait. You said you did 34 minus.
1 is the same as 34 over 34. 34 minus 9 is 25. And then last but not least is to square root everything.
Oh, what just happened? Wait. Oh. Hold up. Not that bad. Wait, 9 over 30. Oh, 30. Oh, got it.
And this is positive because sine in the second quadrant is positive. Sine associated with y in quadrant 2 is positive, sine quadrant. It takes longer when you talk to your friend.
Why don't you
There,
do that?
except
Why'd you put this?
I was an engineer, so I was on that math.
You're an engineer?
Why did you stay there?
What?
I didn't like it.
Wait, that's so much money.
Did you pick high school or you wanted to do high school? Like, why did you go to
I thought middle school.
It's like such a cool flyer.
I didn't like the math. I like teaching this kind of stuff.
Yeah, you like.
I don't like teaching. I don't like teaching little figure 1/3 and 1/4.
Like what?
It's all geometry.
I'm not going to Harvard.
All right, Justin, scroll.
Oh my goodness.
So I want you to try this one
No.
on your own.
Yeah, that's a lot of work.
Why does that never work? Yeah, because I got more to do. I left the easy one for you.
No, I only did with this one because I was.
All right, we're back on. So cotangent, I can relate cotangent and tangent using reciprocal identity. And then you have to pay attention here. I want the cotangent of negative theta. So cotangent of negative theta is equal to 1 over tangent of negative theta. I plug in negative 5/3. And the negative out here comes from the fact that I'm dealing with negative tangent, which makes it positive. And then 1 over 5/3 is 3/5.
I know. I think it
So that is one of the 3 kinds of questions.
So what you're saying?
No, it's
That means harder. More steps. More difficult.
stay confident. Stay confident. The reason generally why we do the easier things first is so that we can build confidence.
Well, what if you just like? What if you start out? What if you start out sucking at the easy stuff? I know. Then you have no confidence.
So then you know you have to learn the easy stuff more.
But,
It's like if I went to the
But
gym
it's
and I tried to
time.
bench press 50, I won't be able to do it.
but there's no way to work on the easy
So I'll start
stuff.
with the little stuff. I play the ball.
But we can't focus on the easy stuff before we go to hard stuff because we automatically go to hard stuff. And then we're just lost.
There's a time. The semester ends in January.
Oh no.
All right, young scroll.
Wait, what? Young scroll?
Scroll.
That sounds like
I don't know.
makes your age better. Young scroll.
Okay. No, next time.
Oh, okay. I thought you said.
I want to give you more time to
Yeah,
practice.
so we don't got any places there, just like, you don't have to.
Practice, just practice.
Practice.
Practice. Effort.
Hey. I'm just trying to, you don't got. Just take it. Just take it easy.
All right, so I want to write cosine in terms of tangent, which means at the end of this, I want to have cosine on one side, and the only stuff on the other side are either numbers or tangent, nothing else. Okay, so no other functions. So you gotta kind of, I guess, get comfortable with looking at certain functions and looking at them through the lens of their reciprocal function. So I'm looking at secant still as cosine because they're reciprocals. So whenever I have secant, I can always have cosine just by plugging in 1 over cosine. So I actually do have a function that relates tangent and cosine. I just have to plug it in. Yeah. Since it's secant squared, it's cosine squared. So right now I kind of have a function of cosine squared in terms of tangent squared, but I want cosine in terms of tangent. And I don't want 1 over cosine. I just want regular cosine. So I'm gonna get rid of this fraction by multiplying both sides of the equation by cosine squared. So I'm calling on your algebra skills.
Oh, no.
And rather than distribute, I'm going to leave it like this because I want to get tangent squared theta plus 1 away from the cosine squared. Yeah. So I have cosine squared times this stuff in parentheses, so I can divide both sides by everything that's in the parentheses. So I chose an identity that related tangent and secant, but I know that secant's the same as 1 over cosine. I wanted to get rid of this fraction, so I multiplied both sides by cosine. I need cosine by itself, so I divide both sides by the stuff in parentheses there. And now I need to get rid of the squared. Yeah, so we have to account for the fact that we don't know what quadrant the angle theta is in. So cosine could be positive, it could be negative.
So,
And whenever we take a square root of something, there's always a positive root and a negative root. So we don't know which one we want. So we have to account for that.
so if there was any type of problem where it was no quadrant,
Yeah. And then I hope that you all know by now that that's not acceptable just yet. What's wrong with my answer?
you can't have a radical in there.
Yeah, so we're going to get the square root on the denominator. I multiply the top and the bottom by square root of tan squared theta plus 1.
So easy.
And there's not really a whole bunch of math to that. It's just... what happens on the bottom is the square root just goes away, and I have the stuff underneath, and then on top it's this times 1, which is just itself. So of course you have to pick the right identity, and you have to do the algebra, but one of the things that I would encourage you to do is make sure that you write each step out and be careful. Because when you start getting into multiple steps and problems, if you're not careful, that's when mistakes happen. So let's try one. Again, I gave you, I think, the easier of the two to do by yourself. You're welcome. So we're writing sine in terms of cosine.
What?
All right, Justin. I should have picked somebody else to scroll.
No, it's
I know. No.
Why do people get afraid of words? Don't be afraid of words.
Yeah.
So there has to be some words here. There has to be a setup. So I want this expression, 1 plus cotangent squared theta over 1 minus cosecant squared theta. And at the end, I want to first write it where all I see are sine and cosine. And then after I get it to where all I see is sine and cosine, then I want to make sure there are no fractions. That's what it means to have no quotients. So I need to figure out how to rewrite these in terms of just sine and cosine. Almost every time I leave my wallet, I have name on it. Okay, so like a couple of the other ones, there's a couple ways to do this. Yeah.
Nice.
I'm going to try and do it what I think is the easier way. So,
What if you're
cotangent squared plus 1, or 1 plus cotangent squared, is the same as cosecant squared.
Alright, well, I already know for 6.
Okay, so again, I'm looking at cosecant squared as if I could make it into sine, because I can.
I mean,
So 1 plus cotangent squared is cosecant squared. I'm just going to continue with the top real quick. And the reason I got to cosecant is because I can write it as sine, 1 over sine. Then I'm gonna do something to that 1 minus cosecant squared. So this is like an aside. cotangent squared plus 1 is cosecant squared. We just used that. We can use it for the bottom as well. Because if I subtract cosecant from both sides and then subtract cotangent from both sides, if I do a little manipulating here, I can get that 1 minus cosecant squared is negative cotangent squared. So again, if I take the same Pythagorean identity, I can manipulate it so that I get 1 minus cosecant squared and that it's equal to negative cotangent squared. No, it takes a little brain power.
Not like this, you should know, in case you had any.
So cotangent is the same as cosine over sine. Okay, and now we're almost home free.
What would you ever possibly use this
To pass a trigonometry quiz or
for? How much
test.
do you get that stuff?
I'm eating outside of school. I got 8 last week.
How many times did you say some of that stuff? It's a
We
vibe, but
do. I like when people say, "When are we going to use this in real life?" I say, "This is maybe not. It's about taking stuff that you know and using it. It's an important. So if I have a fraction over a fraction, I keep the top fraction and then flip the other. I change the multiplication and I flip the bottom fraction. So the signs cancel. And seriously, I have one more thing to do. I'm almost home. I wrote it in terms of sine and cosine.
this is absolutely nothing.
I wrote it in terms of sine and cosine, and now I got to get rid of the fractions. I got it all the way down to negative 1 over cosine squared. To get rid of this fraction, I write it as negative secant squared.
Well,
Aren't you glad we worked through this in the fourth quarter?
okay, yeah.
Normally Trig's the second semester. This would be the beginning of fourth quarter if we did that.
So we're taking the hardest stuff now, and you can chill
I mean, it's killer.
I'm not sure it's
Your share just appears up there
It's
like
less.
negative secant squared is equal to, and you're like,
I
man,
think
that's
that's
way
what
too
you
many
need.
sounds.
I'm not gonna. Yeah, I think that's what
I care.
So I took something I did and I applied it.
That's deep. I should like quote that, frame it.
That should be your senior quote. Why do we do math? All right. Scroll. You got one to try, and then we're gonna practice. 'Cause I'm getting tired.
I think I know my secret.
How was the psych test?
So try this one. I left you with the easier of the two.
One more.
Scroll, will you? Sure. Tell Mr. Campani I said
I'm not going that far. But I mean,
no.
take me up to recording.
I will. Oh, we're gonna. We're gonna.
we will